Hello, I'm Jack Rickard. This is EVTV. Here with my cohort and co-conspirator, Mr. Brian L. Noto, Esquire. What do you know, big
there
guy?
we are. Well, we're here. It's
time to do another show. I've been a little busy, and so you're the only one that knows what we're doing. Tell us about it.
Well, we're doing electric vehicles. We seem to like. We always talk about electric vehicles for some reason.
I like electric vehicles.
Yeah.
That works out.
We're always talking about electric vehicles. So now that we've got something to talk about, maybe we should do a show.
I used to like little Aborigine pygmy whores from South America, but I like electric vehicles
You like that?
now.
You like that?
Boy, there was a group of nuns down there. Whew, about 3 foot tall. They were a lot of fun.
They're kidding you, huh? Well, let's see. What can we talk about? We always talk about Tesla.
What's about Tesla?
The shorts are kind of running away a little bit right now.
What's happening?
They are down to 2.9 million shares shorted in late March.
Oh, really?
And they're at 18.56%.
Oh, they've gotten out.
They're starting to get out. Yeah, some of the shorts are starting to run away.
What are we trading at today?
Oh man, I think when I saw it was like 212. I haven't looked since then.
That's not very tall.
Yeah, I know.
It's not very tall.
No, and it may have been up around 216 at some point. I didn't see the close though.
But that's interesting. The shorts have abandoned us, huh?
I know.
I was getting used to taking their money.
I know. They're getting out. It took them a while.
They get out, the stock will go down.
Our stock will go down. I know.
Which is what they were betting.
That's right. What else? Let's see. I guess they're going to start deliveries real soon in China of the Tesla Model S. And apparently, at least for the beginning, Elon Musk is going to personally deliver the Tesla Model S's in China.
Is that right?
Yeah, that's what they're reporting.
He's going to show up in your driveway with your new Model S.
He's going to show up in your driveway with a new Model S.
You know, I bet that works.
How could that not work?
I was very impressed with Violet, our Southeast Missouri University student from a few years ago was over here. She was very positive about Elon Musk and the Model S. I think that's going to go quite crazy. Of course, it's the top seller in Norway now.
It is, yes, top seller in Norway. Yep.
It's going crazy there. The rest of the car makers are humping and hawing about the supercharger network over there being appropriate European standard and blah, blah, blah. And
I suppose.
it's
that's why it'll work.
the battle with the dealers here is kind of turning. In New
Yes.
Jersey, they've introduced legislation to overturn this, and Ohio and New York have jumped in and said he can sell there. And I think
It's
that's
getting
kind
better.
of swinging his direction. It's still a fun tale to follow.
Yeah, well, you know, it's funny too, and we sent a couple of our new GEVCU contactors to a company in Oklahoma, Miami, Oklahoma, that makes motor coaches, the buses, Newell. So I looked on their website, I didn't know who they were. I thought, oh, why would they need some contactors? They've never sold a motor home, that company, except direct, since the 1960s.
Since the 1960s.
Hello, Jeff Southern here from Kennesaw, Georgia. As many of you know, I wound up buying a Tesla Model S. After driving the EV thing around, found I absolutely loved the car, loved the fact that it's electric. So one of the main things that I really wanted was a car that I could drive every day throughout my typical day as an EV. Unfortunately, in the type of work I do, I'm in technical sales, so I drive all over the Atlanta area. Our sales territory is actually about a 50-mile radius of Atlanta, but because of the way I have to crisscross it to visit various accounts, I may drive 150 miles in a day. So the only EV on the market that can actually do the job is the Model S. I'm lucky enough that I do get some compensation from my company for my car allowance, so it makes the Model S a little more economically viable for me. As Jack has noted, the car's somewhat expensive, obviously, but I actually figured up the cost. Being an engineer, I had to stick it all in a spreadsheet. It really is on the 5-year cost of ownership, it's going to be no more than about a $45,000 to $50,000 car, especially when you compare it against my current vehicle, which is a Ford F-150 EcoBoost pickup truck, which gets an average gas mileage of about 18 miles per gallon. So you can imagine the extra $4,000 or $5,000 in fuel savings versus the gas versus electric cost will make the Tesla a lot more economically viable for me. Absolutely love the car. The performance, the speed, the comfort is just hard to describe if you've never actually driven one. If you haven't been to EVCon, I highly recommend you go for no other reason than driving the Model S, or at least getting a ride in it. I don't think I will have mine there. I'll probably wind up towing my thing up behind the truck, so that just don't have an easy way to get the Model S up there. Maybe if there's another EVCon in 2015, I may work on that as they should have the supercharger network, so I can drive it straight on up there, just stopping 15-20 minutes here and there to pick up a few miles on the superchargers. So here's a video that I put together. It's just kind of the day I brought it home, and then a little bit of a drive. Well, here's the car. It's in the garage charging. You can see we got a blue car with panoramic sunglass roof, gray leather interior. Car's charging up. I had to kick it into range charge to get it to charge because it used so few miles on the way home. We're lucky in that the service center is only about 13 miles from the house. This gives you a little better color of the blue. Just wanted to bring it home, make sure the charging port was working. Everything was good to go, so we're about to take it probably on a drive. Just got the car today, a few hours ago. So I'll back it out and do a little bit more video. Well, here we are about to take a trip in the car. We've currently got it charged up to about 230 something miles. You can see from the pull down menu, the GPS has determined that I'm close to the two garage door openers I have here. So it automatically drops that menu down whenever you're close to your points. I recently got the 5.9 update. The nice thing about the 5.9 update is it adds a few features to the car, which is a hill assist, and the smart air suspension has now returned for the lowering feature. And you can now set the speed at which the car lowers. It's in the settings menu. Down here at the bottom, you can set the speed at which it automatically lowers. I've currently got it set to 70 miles an hour, so it'll automatically lower at 70. You can set it always on, never on, or up to 100 and something miles an hour. It does have the little lawyer warning thing. So that's one of the main features added to 5.9, which was the new firmware update. As you can see, pretty much ready to go on the trip. Okay, we're going to start the trip now. The first thing you have to do is put the car in reverse. You just flip the little lever up. It's telling me that my door's open, so I shut that. Now just start backing out. Interesting fact that the mirrors actually tilt down so you can see the bottom of the car as you're backing out. The camera, of course, shows what's behind you. Virtually no sound, of course. And then if you want to shut the garage door, that's how the home link system works, or supposed to work. Sometimes it's a little cantankerous. And we're off on our trip. I'm going to put it in drive, and we'll kind of do some video at various points during the trip. And of course now it's telling me that I left the charging port open, so I'm going to get out and shut that. So you put the car in park by pressing the little park button. And so the car's pretty smart, smarter than I am sometimes. And it was fussing at me about the seat belt, so now we're good to go. Look for the traffic. It's a beautiful summer day, or early spring day here, I should say. The outside temperature is about 60 degrees. and there's not a cloud in the sky, so it should be a nice, beautiful drive. Okay, we're on our trip. We've gone about 43 miles. We're on a nice highway called 411. It's just a nice scenic highway. We're cruising along about 55 miles an hour. We've used about 14 kilowatts of power, averaging about 327, which is not great, but not bad either. I've played with the throttle a little bit throughout the trip, so you can sort of see how it looks. I'll have Robin show you a little bit of the area. First, we got to wait for this truck here. We got a tractor. You're out in sort of rural Georgia here. This is kind of what it looks like, at least the northern part of it. Wife's taken a couple of drives. She's actually a little bit, excuse me, more efficient than I am at driving it. I usually hover around the 300 to 320 or 330 range. She usually gets it well under 300 on her trips. She recently did one where she fully charged the car up to 265 miles and drove it probably a good solid 200 miles and then was left with about 70 miles of range. So she's definitely a little more efficient than I am at it. You got it?
Yeah, I'm recording.
Well, we're heading through a little town called Dalton in North Georgia. This is where probably most of the carpet in the country's made. This is there's probably like 30 or 40 large carpet mills within probably a 20-mile radius of this town. So this is Carpet Central USA. We've gone about 81 miles. We got about 140 more left on the range gauge. I just thought you guys would want to see what the little town of Dalton sort of looks like. Not much to it, other than carpet mills. Well, we're getting close to the end of our trip here. We got about another 15 miles to go back to the house. We're down to 72 miles of range. We have ran 144 miles. This is one of my favorite little roads here. It's a very curvy little road. I used to love to drive my Corvette down this road. The Model S is just incredibly smooth on these type of roads. It actually handles in a very similar, predictable nature to the Corvette. As you can see, we're curving around the curves pretty good, making the wife a little seasick. Very impressed with how this car can handle for such a big, heavy car. It weighs about 4,600 pounds, so it's a good 1,200 pounds heavier than the Corvette I had, but yet it can handle just about as good, and with the air ride suspension it handles almost completely flat, so very impressive for such a big car. Of course, it's kind of interesting that it's almost as fast as a Corvette. Unfortunately, I didn't get the performance model like Jack did, so mine is probably a half a second slower to 60 than a Corvette would be. But it's pretty doggone close, close enough for me to be happy with it. Really enjoy driving it. It just makes a great cruising car. Just there I noticed that the hill hold feature worked. The latest upgrade to the software, the 5.9, has a hill hold feature. When you're on a steep hill like that, when you take your foot off the brake, it gives you it'll hold the car for 1 second, so you can have time to push the accelerator without having to power brake the car, if you will. So that was a nice feature they added in 5.9. That was a pretty steep little hill back there. Just thought you'd want to see some of this countryside. This little valley is quite attractive. Even thought about buying some land through here. Coming up on the right's a real pretty horse farm. And of course they're selling off some of their land, so you never know. it just amazes me that you can have a car that has the straight line and handling performance of a Corvette, has the room of a big luxury sedan, and it has the economy of a small econobox. I mean, keep in mind this thing actually gets better energy usage than a Toyota Prius. A Toyota Prius tops out at about 60 miles per gallon used in the city where it's best. This car can easily top 100 miles per gallon equivalent energy use. So kind of amazing that you can have that kind of performance, luxury, room, and handling in a car. And of course what makes it possible is the electric motor in the car. If this was a gas-powered engine, you would be a much more front-heavy bias, which would make the car want to dive more into the curves. This is more like a high-end sports car where the motor's between the rear wheels, which would be considered a mid-engine car, and it makes a much better dynamics of the way the inertia in the cars do as you move it around a curve. I mean, I'm going around this curve at about 50 miles an hour. Of course, you can ignore the speed limit sign there, and it's just as smooth as glass. Anyway, just thought you'd picture seeing this particular portion of the drive. It's rather scenic. Well, here we are at the house. Here you can see the end of the trip. We did 158 miles. We were using an average of 311 watt hours per mile. So that's kind of the trip gauge. As you can see, we have, I don't know if you can see that, but we have 57 miles left on the display. Again, it was just an absolutely beautiful day for a drive. So that was kind of our trip, just sort of uneventful, nice Sunday afternoon drive. Thought I'd show you another nice feature of the car is it does have I do have the parking sensors. As you can see, they just activated. It's telling me that I'm getting close to the wall, and it actually, when you get close enough, it actually tells you how many inches you are away from the wall, which is kind of interesting. As you can see, I usually drive in until I'm about 18 inches from the wall. So that's kind of nice. I can stop right on the same spot every time, and it tells me exactly how far away I am from the wall. Thought I'd do a walk around of the car. It's kind of in the sunshine, so it's a nice pretty day. This is the after we finished our trip. Just thought I'd let you see what the car looks like. One of my favorite parts of the car is actually the rear profile. I think it looks a lot like a Jaguar, which it probably should, since the guy that designed it is actually was the one that designed the latest Jaguars. My car is the blue car, has the light gray interior with the sunroof, panoramic sunroof in it. When you walk up to the car, of course, the handles come out, greet you. And this is kind of what the interior of the car looks like. Again, it's just a light gray interior. I think it looks really good with the blue. Rather large back seat. Doesn't have a lot of headroom. But just thought you'd like to see a little walk around.
Always done it direct.
That reminds me, they're not bankrupt, but they're ceasing operations. And this is kind of interesting. Of course, we keep an eye out for these bankruptcies, you know.
Should we start playing the Sanford Son tune right now?
Elizabeth, Red Fox. Yeah, put in the Sanford and Sons theme song. I'll have to dig that out.
I have to dig that up, I know.
The Smith electric vehicle in Kansas City, originally from the UK. They've done some, they had a program of $34 million in government money to do 520 heavy trucks, not over the road, but delivery trucks.
Like delivery
and stuff.
trucks, big vans, yeah.
And they've done it for Coca-Cola and Frito-Lay, I think, and the Marines, and they did about 400 and something of them. The government's very curious to see if that gets completed. Meanwhile, they have ceased operations as the business not being viable, but they haven't really said they're declaring bankruptcy just yet.
Okay.
Smith Electric Vehicles kind of interesting for us because they wound up with the intellectual property of Azure Dynamics, including all the rights to the DMOC 645. A little birdie told me.
Okay.
If I only had someone there to talk to, we might be able to, for a small cash settlement,
Anybody out there listening?
get some stuff that they're not going to use anyway,
They're not going to use it now.
and be able to make DMOC 645s.
Let's see, what else? Just the last thing on the Tesla front, it looks like they are going to do a business leasing for the Model S's now.
Really?
Yes. So they put a Tesla Finance, I think is what they've named the company. Makes a lot of sense. So they have a 3-year leasing that they're going to do for businesses.
And is that a special model that's over 6,000 pounds?
Well, no, just the old Model S. That's right.
Not that I know anything about the tax code.
That's right. Exactly. Yeah. What else?
Look it up.
That's right.
Pretty good living.
What else going on? Apparently, GM has. They're going to continue the Volt with gusto. They're increasing the battery capacity that they're doing. Their commitment to the Volt. Apparently,
I actually
like
talked to Mary Bruce, is it about that?
Oh.
Asked her a series of questions.
Yeah.
And she said she doesn't know. It happened before her watch.
Oh, okay.
They are looking into that, and they're going to get to the bottom of it. She doesn't know.
Doesn't know.
But they are investigating this Volt thing.
Okay.
And she's not sure, but she thinks that happened before she got there. And she doesn't know.
She doesn't know.
But General Motors, home of the Shred Me EV1,
Yes, I know.
is vowing renewed commitment not to hybrids, but specifically to full electric cars, of which they make precisely one.
They do. They make one.
The Spark.
Yes.
And you
that's right.
can't have any
That's right.
because it's a CAFE compliance car. They
Yes.
make about 100 a month.
Yeah, it's only good for California. Yeah, let's see.
It's not that I disbelieve you, General Motors. It's just that whenever I see your lips move, I know you're lying.
Well, apparently the Canadian government is selling all of their investment in General Motors too.
Is that right?
Yes,
So that's where the shorts went.
that's right. That's where they went. That's right. What else we got? We got a couple of bits of racing news. Monster Tajima, who was raced in Pikes Peak for the last 3 years with electric vehicle.
We've been following him.
Yep, he is going electric again.
Is he?
This year? Yes. So he has committed after last year's kind of crazy smoke release in his permanent magnet motors. He's back again. Yeah, he's going to be back again, and that's June 29th. So we'll keep giving you updates on the Pikes Peak, but the monster is back. We'll see if he can tame Pikes Peak.
By golly. What else is going on in racing?
Well, last week I forgot to report this. Sorry, John, but John Metric had posted a new NEDRA world record in the assault and battery.
Congratulations, Mr. Metric.
His Miata. So he did a 1/8 mile at 5.730 at 126.26 miles an hour.
5.73 seconds. That's very quick.
Yeah, you're talking a
I don't
fast
even know
car.
about these things, and that's pretty
Yeah,
quick.
that's a fast car. He holds the record in the quarter mile at 9.13 seconds. He made a quarter mile run at 8.913 at 147.99 miles an hour, but you have to make a backup run. You have to do it twice, and he just couldn't get the backup run. So he's got a target, and we've got a
Sub 9 second.
sub 9 second. He's got a target there. So he's made a sub 9 second run at about 148 miles an hour. So he is going after now rails and anything on wheels that'll go down a drag strip.
Wow.
He's it's going to be interesting. What he did post, which was kind of cool, was this minute and 47-second video
I like videos.
where he has put a GoPro or similar type camera in the motor bay on the front motor, and it's pointed at the commutator. And I think everybody will find this kind of interesting.
So it's kind of a GoPro slag now?
And it's yeah, we should take a look at it and see what we got.
Let's see what we got here.
Yes! Yes! The first run in the eighth, man! Woo! We did it! Woo!
I knew those DC motors. I knew
That's
what the
some
problem
plasma,
was.
baby.
That's why they're burning up on the freeway.
That's why they're burning up on the freeway, because that's what it looks like. Yeah, that's what it looks like.
That's
It's bright and white and stuff flying everywhere. It's
you
pretty
don't
cool.
want to be close to that.
No, and it didn't blow apart. He said that there was no problem with the commutator or the Hellwig rushes. That just makes a lot of plasma. It's pretty cool.
Those plasma balls will burn you with the light.
Yes.
Don't ask me how I know. Without ever getting in them or near them.
No.
Just the light. It's like welding torch 6X.
Yeah, right. Yeah, it's amazing.
You can get a skin burn from the light off of it.
Yes.
But that's pretty good video work, John.
And I did learn
We
something
might have
else.
a place for you.
That's right. And I did learn something else. And you know, you have, I remember you did one of the Sunday shows. I think maybe before you actually did the first little Sunday show. And I think you were in maybe your bathrobe or something.
Yeah.
Yeah.
I was in my bathroom smoking a cigarette, playing with the software. I looked up and there's 25 people
There's
watching.
people there watching you. I did learn that
I don't think we're going to do that anymore.
it's a lot of work.
It's a lot
and I
of
didn't
work.
even do it.
I still don't get the point.
But I did learn in that vein that apparently both Ernest Hemingway and Ben Franklin like to write in the nude. So like to do TV in my bathroom.
And
What the heck?
And Winston Churchill was big for writing in his bath. He liked to sit in the bathtub, smoke cigars, and do his writing in there.
So there you go. So we're in good company.
So get off my hands.
That's right. So leave me alone. But that's it for the news.
Well, very good. What does that bring up? Let me. Yeah, I don't know what we're going to do about this live show. I never did quite get the thing. I just was kind of going along.
Yeah.
I thought our viewers knew what this was about, and I could be trained because of what happened with letters to the editor in Boardwatch.
Yes, right.
Well, I guess I don't get it.
He gave it a whack and still don't get it.
Yeah,
That's right.
we tried this, and it's 2 or 3 hours out of Sunday afternoon, and it sort of wanders aimlessly, and we chit-chat about nonsense. I guess I just don't get it, guys. We may try it another time or two, but
When you're kind of in it for the duration, they can wander in and out and come and go, and you're kind of there till the first guy is in, last guy leaves.
At any one point, we'll have 75 to 100 people watching it, but it's. I guess I just don't get it.
Yeah, no, it takes a lot of time on Sunday.
Yeah, I'm always late to Sunday dinner now. I get in trouble.
Well, you got Easter and everything coming up soon too.
Well, our European guys all drop off pretty quick because it's later there.
It's later there, yeah.
And, they're likely the most likely to benefit from it. So I don't know. But it doesn't make much sense to me. Speaking of European guys, Anna gave me a cracking minute 40 seconds last week.
He did, man. I was exhausted watching that.
I was drained.
Yeah, man.
He kind of made up for it. He's got some stuff going over there. Let's take a look.
All right.
Well, hey EVTV, this is Anna Kloppenborg with your EVTV Amsterdam update. I'm sure you missed me last week. I kind of left you guys hanging without a real update. We generally shoot our EVTV updates on Friday morning European time, which is like midnight in the United States. Only last Friday I was at home as my wife pulled rank on me and I got to stay with my sick little boy who was not able to go to daycare that day. He's all better now, and I've been at the shop this week moving on with our builds and our warehousing of components, sending them out into the EU for different builds. So that was last week's problem. We're back here this week, no problem at all. This last week we have some 818 updates in the sense that we moved ahead with converting the original WRX transmission from a 4-wheel drive setup to a 2-wheel drive setup. The manual that you get with the 818 kit really explains well how you do this. You kind of put her on the bench, you take off the rear mounting plate and basically take out the whole rear diff. And they add a new cover plate in the 818 kit, plus the whole details how to do it in the manual. So all in all, it was a cool little job to do. Plus, let me just check we got levels here. Yeah. So all in all, it was a cool little job to do. Plus, it shows again how the 818 kit really, it doesn't assume that you already are, an advanced mechanic as it goes for automotive components and that kind of thing, knowing how transmissions work, which is great because we as boat guys really don't know how transmissions work. So they take you through it step by step, and before you know it, you've adapted a 4-wheel drive transmission to a 2-wheel drive, and we move it further back into the car, put on the rear wheels instead of the front, and hey presto, it becomes a mid-engine rear-wheel drive sports car. Having upgraded or basically converted the drive, we're now ready to move ahead and get that coupling situated, plus that we're doing a lot more of the measurements in the car. Unlike Eric Chris, who has things measured out before he even buys stuff, basically has books written and EVCON talks given before he decides whether or not a project is worth doing. We're kind of the other way around. We fall in love with the project, figure hey, we'll try and make it work some way. Let's get that baby in here. Which means that a couple of months into it, you start scratching your heads going like, how's this going to fit? So anyways, we've got Ray definitely measuring it out, and where there's a will, there will be a way, and I'm sure we'll get it in. The 818 is continuing to draw some attention. It's definitely a popular model, and it has opened up our eyes to the amount of kit car, custom car enthusiasts that there really are out there here in Holland. We really didn't know about it so much. We're boat guys, not so much car guys. But now they're coming out of the woodwork, and we found a great company, Speed-On, which is only about an hour down the road from Amsterdam, that invited us to come visit and talk kit cars, talk future possibilities. Speed-On to me is really the kind of company that proves the point Jack's been making, that there is very much both a DIY and professional market for EV and high-performance EV components, even after the tech adoption curve has been there, and even if all OEM cars are electric, there's still going to be this desire for either upgrading or keeping on the road of classic cars and boats that people love, and there's going to be this performance desire and a drive your own way desire, being able to do something with your own hands or to your own tastes. Speed-On to me is the company that really proves this. I mean, here they are completely focused on large gas-burning engines and conversions of, middling power to ridiculous power, redonkulous power even, or upgrading classic American cars and keeping them on the road for people that have a passion for that. There's people who have ample opportunity to buy off-the-shelf parts or buy completed cars, yet they come to a company like Speed-On to help them build their kit or find a kit or upgrade an existing kit or upgrade an existing old-timer. Misha, who started the company 10 years ago, now has 10 FTE full-time employees working for him and in his company, just to keep up with demand and serving this very demanding crowd, but also a crowd that'll spend some money on having things their way. Obviously he's getting some more of those questions that some shipyard builders are getting as well, like, hey, what about electric? I hear electric's pretty good, especially for certain racing and crossing. It's really, they say it's all about torque, much more so than it is about horsepower. So a lot of people are very interested in electric. Vice versa, we're in the market for services that a company like his, a lot of challenges they have on a daily basis with motor mounts and adapter plates and couplings and clutches and upgrades of automotive components. If we want to go forward and be a shop that'll do, car upgrades or car servicing or, EV servicing in the future, we're going to need a backup of knowledge and parts and buying power in that kind of automotive high-performance market. So we're kind of reaching out to different partners for that future, plus sniffing around and looking at their business model as an example of where the EV high-performance shop could be going and where the customers could be coming from. I mean, we need this to be a business for it to be a market. So that was really exciting and really cool to see. Plus that he gave us the tip that there's a car out there called the Saker, which is also using the WRX transmission, using it in the way that we do, converting it to two-wheel drive, putting it in the rear and having it drive the rear wheels. And there's a whole class of competition using these basically kit cars. So the Speed-On company really advised us that once we have the 818 out and rolling, we should cruise down by the company that organizes the Saker races and show them, hey, we've got a drop-in kit for your drivetrain, basically. So exciting developments on the car front for us, the boat guys from Amsterdam. Has it been all cars this week? Well, no, not really. Last week you saw our tiny little time-lapse segment of us disassembling the Delta. Well, we finally had that new prop that I've been moaning about for 4 months in. Why are we taking her apart? Well, the new prop was tested, and even though I was definitely excited about the extra ability of the slightly larger prop to put torque to water, our main issue with vibration and noise hadn't really changed that much. Plus, even though other people were definitely impressed with the performance, being a guy that's done a few electric conversions and has sat in many high-powered conversion at EVCON events, I was all kind of like, meh. Where's the real pickup power? Where's that EV grin? I was more like EV instead of EV yeah. So we knew that we really wanted to kind of revisit the motor and drive setup, especially going forward towards now wanting to offer limited run productions of new Deltas. And you got to have a good idea of A, how to market that and show how the original Delta came out, and B, have to have a really good idea about how you want to place your motor and the kind of experience that you're going to be offering to people, besides the fact that it's going to look really cool. So we disassembled the Delta and we brought her over to Middenmeer. Dick Gillis of Gillis Botenbouw is our new partner that will be building the new Delta, and he's also going to be our partner in revisiting the drivetrain setup of the original Delta to make her better, faster, and more dangerous. I went over to Middenmeer and visited with Dick and checked out what he was doing with our original Delta. So let's take a look at that. Okay, well, hey EVTV, we are here with the Delta, and she is in Middenmeer and completely on the operating table. I'm standing next to the surgeon and general and boat builder, Mr. Dick Gillis of Gillis Botenbouw. Dick and I met at the HISVA boat show that you all got to see on one of our previous updates, and at the time I was shopping around for someone to join Project Delta and build us a new one. And Dick Gillis is going to be the man for the job. How you doing, Dick?
Excellent.
Excellent.
Certainly no. And we are at the beginning of making the Delta better as she was before, and also making the new Delta.
Exactly, which is a great thing to do.
Yes, yes.
So you were walking around the HISVA boat show and you saw this shape, got to talk to us a little bit about the thing. What do you feel about the project of the boat, the size of the boat, the drive line, and what we're trying to do here?
Fantastic.
Yep.
It's the new driveline.
Mm-hmm.
I mean, this boat was made in the 50s with a petrol engine, and now we are 50 years further, and we have an electric drive train which is going to be in there, and we are going to water ski with that, and it's going to be perfect, better than what was before.
Exactly. And you've seen the little movies, and I'll put them in this week's update. Marilyn Monroe types water skiing in the 50s, to then bring that to 2014 should be a kick.
Yes, certainly.
Yeah.
And I think we can do that as well with the Delta,
Yeah.
With an electric propulsion, because there's enough power.
Yeah.
And as long as the batteries last, we will be able to water ski.
Well, exactly. Dick and I went out on the Nieuwemeer with the current Delta and her now previous driveline setup. Dick definitely wasn't scared to put on the throttle, and you'll see in some of the video that I was looking kind of scared for a moment there. We had some really choppy water. As for the electric drivetrain, you told me that up till about 10 years ago you had some experience building different drivetrains, and at the last boat that you built, you were spending about 15,000 euros for 10 kilowatts, was it?
Yeah, thereabouts.
Thereabouts.
The last boat I built with an electric drivetrain, I did build in Amsterdam a fleet of boats, rental boats, some 20 of them, with a very small engine, only some 2 kilowatt electric motor, and that was more than enough to propel a boat up to speeds of 6, 7, 8 kilometers an
Sure.
hour. We even had to
Tone her down.
Tone her down.
Limit.
Indeed. Yes, limit her, because it was going too fast.
Yeah. In Amsterdam, they say you're allowed to go faster than walking, slower than a bike. If you're passing bikes while you're in the canal, you're being a bad boy.
That's right. That's right.
Yeah.
And you make waves.
Yeah, exactly. So you're a dick, basically.
So, but in those boats, we had a different type of electric motor, a permanent magnet motor, and that was all right. But to go fast, you need a different motor. You need a asynchronous motor, as we called it in those days. I think it's still the same now.
Yeah, absolutely. These are the AC, and the ones we're using have an inductive motor, and now we're going from the air cooling to the water cooling, getting the higher power levels. But really, like Jack often says, it's really all about the batteries. Regardless of the price of the motor back then, especially looking towards planing boats, we need the power density and we need the capacity on board without the boat sinking for weighing too much. So that we can now get a total drivetrain into a new Delta, at or under 15,000 is the real target, so that you then have a marketable product, both in drivetrain and in boat, I guess.
Yeah, I think that depends on the price of the batteries. That's and how the size of the batteries, the price and the size.
Yeah.
And that's the big part.
Yeah.
Also, you need quite a lot of power as you're driving fast, because I've got a boat here which has a diesel engine of 180 horsepower, and I put a hybrid engine on top with a lithium battery.
Right.
But that's a small battery.
Yeah.
And then I also was in that price range of 15,000 euros.
Yes.
But it's just a 2 kilowatt motor.
For an add-on system.
For an add-on system, for just driving slowly and without any noise also in Amsterdam.
In the canals, exactly.
In the canals, yes.
I've took some pictures of this system before, and I'll show them while Dick is telling us about it. It lets you basically turn off the diesel engine and engage the electric system in a what's then more like a parallel hybrid instead of a series hybrid system. Yeah. And so you have that low maneuvering speed for zones where you're either not allowed or would rather not have diesel or petrol-based propulsion. So you're quiet, you have no emissions, and then when you're outside of the locks onto the big water, long range, high power, you re-engage the system. So that was basically the state of play at that moment.
The advantage of a lithium battery is that I could make a totally electric hybrid system with only a weight of 100 kilograms. And that's an important part.
Right. You don't want to lose passenger capacity. You need to.
No. Otherwise, the boat's going stern down.
Yeah.
That's not good.
Yeah, no, exactly. In our Glastron, our original conversion, it originally had a 6 people occupancy. We were definitely down to 3.5, 4 people after the conversion, because that was not the most efficient form of boat. She was old. We had a lot of battery in her. So it's always been this challenge, which is part of the reason why we're here with the Delta. Lightweight, aluminum hull. The percentage of weight of batteries versus the total boat is going to be a higher number, and you'll just get more range out of the same amount of battery. So it's a good platform to show. Yeah.
Also the design of the new Delta is slightly changed to compensate for the extra weight of engine. Yeah. By the batteries and by the engine itself. So therefore, we will not lose quality of sailing, quality of.
You don't want to make a heavy, tubby little boat. She wants to be just right for her length and weight.
Yeah, that's right. That's right. Yeah.
Hey, and just to finish off, the last thing we're doing here is to make sure that when we're presenting a new Delta around, that we also have a newly thought out drivetrain setup, because in the original, what I did here differently than with the Glastron and the Netcraft is that we took a existing system, but we replaced it with more torque, more RPM, more power in a setup that was older than the other setups that I'd used. And what we came out with, as Jack lovingly called the growl, or the electric banjo, was a system that just had more power than the prop and the setup could really handle.
Yeah, especially more RPMs.
Right.
and that was the big problem. I think there was a lot of vibration, and when a propeller drives too many revs, it starts to cavitate. So that's what we are trying to take out now by reducing the RPMs of the prop shaft with a belt propulsion. And it's going to be 1 to 2. So when the engine makes 5,000 revs, the prop shaft will be 2,500.
Yeah.
And for that we have a different propeller, still a lot bigger than the propeller which you...
Bigger is better.
And a different shape as well.
Yeah.
And,
absolutely.
And I hope we can get enough power in the water, because there is enough power on board.
Yeah.
The engine is strong enough.
Yeah, there's no problem there.
But how are we going to get it into the water?
Yeah.
And have this fantastic feel of going from 0 to 60 kilometers an hour in just 3 seconds or something.
Exactly. Well, and that's really the feeling, the EV grin that we were kind of missing in this boat. Everybody that I took out was thoroughly impressed. Ourselves, since we felt how the Glassron and the Netcraft behaved, we were kind of like, meh. It's not quite what electric can do yet. Plus, you know, having the noise at the top end, kind of other people were going, hey, you got a 2-stroke in there? What's going on? You know, so we really want to get that quiet, high-speed cruising and that whole shot. So in the next couple of weeks, we'll be updating as the new engine and setup go in. I'll be overlaying this whole talk with some of the pictures that we made of the new prop and the new setup and the belt drive. And probably in about a week or 2, 3, we should have her back in the water and showing you all how it went out. That should be right?
Absolutely.
Okay, well, Dick, it's been really great talking to you here. I'm really enthusiastic about the new drivetrain and looking forward to seeing a new Delta arise from your shop.
Well, thank you for the opportunity, and it was very nice telling about my thoughts in this project.
Cool, man. Thanks a lot. Take it easy.
You're welcome.
So that was me and Dick Gillis, really a great guy, and I'm very excited about having him and Jan Visser, the naval architect from Friesland, involved in the Delta project. As we are really the drivetrain nerds that are very enthusiastic, it's very important that we find and partner up with people that have both the nautical experience, background, skill set, and labor ability of building, designing drivetrains in boats. And then on the car side, it's very important that we're working with companies like Humming Performance, Speed On, the custom car guys, just to make sure that when and if this market does pick up and we have more people to serve or people that we can help out with their builds, that we have the right kind of network here in place and locally, so we can help them out and maybe even start serving these other companies with drivetrains and training of our own. This way everybody does what they're good at, and we all serve more customers and get more EVs out on the road or the water. So that should be good. Anyways, real exciting stuff for the Delta and the 818. And yeah, so got this going. So anyways, real exciting stuff for the Delta and the 818. Definitely moving forward on both projects. For the EVTV Amsterdam warehouse, this week we had a pickup of 2 crates of batteries going to Ireland, 1 load going to our famous Damien Maguire for the JTM Power. They probably have a little 24-volt action going on there. And the other is a little pallet of 40 amp hours going to a motorcycle conversion. A couple of months ago, we had Eamon Stack buy some batteries from EVTV and put them into a Vectrix and now has over 80 miles of pure electric range that he has convinced a buddy of his to do the same with a slightly lighter bike and 40 amp hour batteries instead of the 60s. So within a couple of weeks, we went from 0 bike builds to now 1 completed and the other on the way. Should be real excited. And the final package that was picked up was a HPVS AC75 system with a 144 volt controller going to the UK. So we'll be serving another car build with HPVS kits over in the UK. This is after our first build, which was the Toyota, like a 6-person Toyota van built in the Isle of Man already last summer. So we're kind of moving up with the builds there. It's definitely the car builds in the England with the easier MOT that are leading the way, and hopefully a little later in the year we'll have some more stuff that's road legal here in the Netherlands and Germany, and show you all that. Anyways, that's about it for this week. We're going to keep on building. You keep on building, and we'll see you next week. Take it easy. Bye-bye.
Yay, Anna.
No kidding.
Yeah, that's pretty nice.
So they're talking about a 2-to-1 gear reduction.
Yes.
And that guy he's talking to,
Yeah,
Priest.
yeah, whatever. Yeah, I can't pronounce his last name.
just,
Yeah.
that's my boat they're building. But
Yeah, that's
he's
what I
having him
thought.
redo his first.
Yes, I saw that.
With a new-
He's got his
They're
Delta
gonna
in
do
there.
a new 2-to-1 belt-driven reduction. Increase the angle, that'll let him use a bigger prop.
Bigger prop, yeah.
And so a kind of a dramatic change to the drivetrain on the Delta, which I thought was running pretty well, but still growling.
It was still pretty loud. Yeah, yeah. Yeah.
And so I think that's kind of a good thing. But my Delta's on order, and there was some implication that they might be improving it for weight and trim, from what they know.
Yes, I think so.
And this guy seemed to be a veteran
Yes.
boat designer, and so that was originally the Albatross, and then it morphed into the Delta when the guy that was the head of the Albatross company got leukemia in
Oh.
the early 60s,
Okay.
and basically just kind of shut it down. And a couple of the employees went on and made the Delta. But anyway, a little speedboat, and it was zipping around
I
there.
think so.
It was actually, I think, probably a little smaller than the Delta, but that's going to be coming up. I've heard from our guys in Alpharetta, Georgia.
Okay.
They have, they're laying the, what do you call them? The ribs.
The ribs, I was going to say. Yep.
For our Aristocraft Torpedo
Nice.
16-footer. And so we're going to have 2 boat projects going at the same time.
Oh, that'll be
It
fun.
would be neat if I had a little short, fat motor that would put out quite a bit of power.
Short, that maybe doing 100 kilowatts or something?
Yeah, and for about 100 pounds.
Wouldn't that be something?
And then some of our coming Cam 80 or Cam 72 battery
yeah,
cells.
the cams, yes,
in one
nice.
of these little boats.
That would be pretty cool.
If we could just get it to turn.
If we could just get that to happen.
Let's take a look.
All right.
Hello. Man, is it fun to fall on our own sword. I'm here with Mark Weisheimer. He's a communications engineer with Associated Press.
Correct.
And he happened to be over in Nashville doing the women's Final Four. Apparently they let them play basketball now, the nappy-headed. Well, anyway. So he was in the neighborhood and stopped by to play with our UQM Powerphase100 test bench, which I introduced you to the other day. We've kind of set it up and have a battery pack now connected to it, and the inverter and motor connected. As many of you noted, I can't do very well with my three-phase rectifier. So Paulo's actually talked me into putting a GEVCU on our Siemens generators now, so I can actually vary the load and show that on the screen. So the test bench has kind of grown on us a little bit. And Mark came in Thursday morning, actually, to help build this up. And it took some effort. We found out some interesting things. We don't have the GEVCU quite working yet, which is a damn shame.
Close.
We decided to use some battery packs that weren't really any good for anything. With the Better Place battery packs, we got two that Omer Bar Yochai told me were A123 versions. I can't find A1 to nothing on these batteries, but it looks like a little more advanced version of this thing. Mark wired it in, and we're actually using the contactors on the pack. What did you find, big guy?
Well, I found it's got the same number of contactors that the other packs have. It's a little newer build, so it's got some improved bus bars and some things like that. It's got the same lithium manganese spindle cells in it, so 3.9 volts per cell.
So
And
it
then
can't be a lithium iron
it
phosphate
can't
cell.
be lithium iron phosphate. It's got to be LMN. So
And the modules are marked just like the
Just-
AZS
yeah, exactly.
modules that
Yeah,
Nissan puts out.
yeah. But they changed just a few things, just a slight change in the structure. It does not have any air cooling.
Right? All
It's
air
a
cooling.
completely sealed can, so that was interesting. But the contactors, it has the two same contactors where it has a big contactor on the plus leg and a big contactor on the minus leg, and it's got a third contactor for the pre-charge. So you can, it will pre-charge, and then you can bypass the pre-charge resistor with the small relay. So we wired those all with 12-volt power and switches. We have that all here on the edge of the bench, so you can bring up pre-charge and ground and pre-charge the unit, and then you can bring the high voltage online and completely bypass the resistor and bring everything on full power. So that's done, and those are the 12-volt controlled relays.
And then the last controller switch on our panel is just 12 volts.
12
to the
volts
inverter.
to the inverter, and we've also got it into the GEVCU.
And we put in a little 5K pot, actually kind of a nice one.
Yeah, another 10 turn.
And so, yeah, that pack, it's smaller.
It's smaller as far as total amps, maybe, but and physically smaller.
No, I mean physically small.
Yeah, it is a little
It's the
physically
same
smaller.
number of modules.
Yeah, as the other better placed pack,
The can that goes over it has no openings, really.
and it doesn't have the heat conduction devices inside.
Yeah.
So I mean, they're basically corrugated metal, but they would transfer the heat.
They were nice.
It would give you the idea that as time went by, maybe they discovered the heat wasn't such a big issue for them because they took the cooling out. So,
There were two of them. They're brand new. They've not been touched.
oh no, they're new packs, and just a little bit newer. Just as you say, they've shrunk it down a little bit, and not surprisingly, the others were way overbuilt. These are overbuilt.
Well, they are. You can't put them in a car with all that base on them.
Yeah.
I guess they did,
It looks like they did,
but I can't put
Not
them
for
in a
long.
car. But you know, a test bench doesn't have to go very far.
no, and they're
Or
a
very fast.
Great test bench pack, beautiful, and they would be just fine taken apart and put somewhere else in a different way.
They would be, but we actually kept it all together, and so Mark kind of figured out the 12 volt. What we there's a connector from the BMS to
From the BMS, right? That
to the,
controls those contactors.
to the contactors, and he unplugged that, and we stole one from a disassembled one, the connector,
Yep.
which was the same,
Yep.
and then just wired into it, and he figured out which wires turned on which connector, and I actually we gave them all 12 volts, and I had him bring out the grounds,
Right.
and that way I could switch that
Absolutely.
with the GEVCU, which has kind of a open collector type MOSFET that it's a switch ground output.
So what it does is takes the line you give it to ground. So if you 12 volts through a relay is perfect, and then it'll take it right to ground and
Right.
turn the relay on.
So that's pretty cunning. So we've got the bench up. We don't have the GEVCU connected, and in fact, I didn't really care if we were under load. Our mission here was actually about doing a module for the GEVCU to turn the motor at all. And we have failed rather considerably.
Or not spinning the motor.
Which is always one of my favorite modes. I learn a lot more failing than I ever do winning.
Yeah, yeah.
But by yesterday noon, we had every CAN message this thing transmits decoded, and it actually it puts it on the screen here.
Yeah.
I can read the voltage of the pack, the current, the torque, the temperature of the motor, the temperature of the inverter, the RPM, all of it. It's done and actually displays on the website of the GEVCU.
Yeah, yeah.
Interestingly, the DMOC 645, we have 5 different commands sort of outlined in there. I don't know. I think we actually send about 3 of them.
3 of them that change, right? Yeah.
And so this one has one command frame that has torque and RPM limits in it, and that's all it wants to turn the motor.
Yeah, yeah, basically, or enable and forward and just some things like that.
Right, there's
or
a couple
reverse.
of bits that
Yeah,
set the
yeah.
direction and enable it. And,
But it's all accomplished in
and
8
then
bytes.
a torque command.
So,
Yeah, it's all accomplished in 8
One
bytes.
message.
one frame is all we have to send it.
yeah.
So would you believe
We're struggling with it,
we can't?
but we'll get it. So,
So
devil's in the details.
by noon yesterday, in 40 minutes, I did stay up the night before a couple hours writing
Yeah,
this
yeah.
thing, just a basic outline of a object module to run a inverter, and the original premise of GEVCU was that these inverters are not too different. And that premise is holding true. We're talking about all the same things.
Yep.
The voltage, the temperatures, the torque, the RPM. It's really a pretty limited set of things.
It is.
And this one is, the code wound up being a fifth of what the DMOC 645 may have been a good one to start with.
It might have been the hardest.
It's kind of complicated compared to what I'm seeing
Yes,
in
it is.
the Reinhardt, and this UQM is just
Yeah.
a PUD,
Yeah.
except we don't have it working.
Well,
40 minutes into it, we had everything it puts out. We're setting up the camera and getting ready
Yeah.
to shoot. We left at 12:27 this
Last
morning,
night.
12 hours later. Mark came in early this morning about 8, and I came in a little bit later, and we've been on the phone conferring with our mentors and so forth, and we get
we
to go
still
home
don't
a
have
loser
it.
today, buddy.
Yeah, we're going to go home a loser. We have technically lost this one, but not by much.
Not by much.
And the way you win the battle was you keep coming back at it, and so we'll get it.
Persistence is
Yeah.
all of it.
Yeah.
For Ed Pizant and some of our other personal computer wizards, we had a Macintosh, 2 Windows. Mark's got what's your CAN bus stuff? You got a Kvasir?
This one, we have Kvasir Leaf Light, and we also have the microchip CAN analyzer, which is great for displaying data. And it's inexpensive. It's $100, and USB interface, and I kind of like it. It's a good one for monitoring, most assuredly. I don't love its transmit capabilities. You know, as we were playing today, you could whip through the GEVCU faster and make changes and blast data out. Endlessly,
by
and this
today
one
we're
doesn't.
doing listen to the GEVCU because
yeah.
it's just a text file. I can just make changes
Yeah.
and recompile it, and it goes out quicker
Yeah.
than
Which
the
is funny because
the little panel. Now
ought to be the
they
other way
have some
around.
very advanced CAN analyzer software. In fact, I think it's called Canalizer.
yeah.
It starts at about $6,000.
Yeah.
I don't know a lot about it because of that.
It's a little out of the price range, but you know
But
that's
these-
$100, and there are some others out there.
This was nice. He had he could actually monitor the flow of both the inverter and the GEVCU, kind of like a sniffer.
Yeah, very handy.
And then we had a serial connection to the inverter where we could see its front panel.
so we could compare notes. We were with it. I mean, immediately.
It flashes little lights at us.
Yeah. Yeah, but like the voltages and the temperatures, those got dialed in quick. So.
Yeah, it was 40 minutes, and we had
yeah.
everything coming out of this.
Yeah.
But all we have to do is come up with one command.
Well, I think it's going to be an enable or something of that nature, but we'll get it. You know, there are codas out there that operate, and it'll be in there somewhere to be sure.
Yeah.
So.
We're probably going to have to get somebody to log some
Yeah.
live coded data for
That
us.
would be very helpful.
Because it appears that this inverter is not precisely the standard firmware
No, it doesn't go by the book.
in the Powerphase100.
No. Close, but
There were some anomalies.
yeah. Well, the data it sent proved to be right by the book.
It was right out of the
Right
book. That's why I'm
textbook.
surprised we didn't.
Yeah, I agree.
Didn't
I
win.
agree. But maybe it'll end up being two commands, and then we'll be there.
Yeah, it was so by the book that I'm really surprised. I still think it's.
Yesterday we were
I'm still
ready to
like
break out the
fishing out
ship.
terminating resistors and wanting to swap the two wires one more time.
Yeah. Yeah. Isn't there a problem here somewhere? Yeah, there is, but it's probably going to be in the CAN command.
Normally, and this is like the standard frightening term from a lieutenant in the Army, according to my experience, or a chief warrant officer, watch this shit. Yeah.
Yep.
But it's been my experience that the harder you struggle with a problem to get it to work, and the longer that goes on, the more likely in the end it is to be something stupid.
Oh yeah, like a terminating
And
resistor
really
or
simple,
something.
like a terminating resistor.
The wire
or-
came loose. Yeah.
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 Find a wire laying on
Well,
the ground.
we had our little adventure in something like that with a wire. So somewhere we finally switched wires and voila.
Yeah. So it's been an interesting couple of days. Yeah, like the pack, we're going to continue on the test bench. So far, it's test bench 1, Ass Clown 0, but we'll keep after it. I'm sending Mark home with some goodies where we can
Make some more progress.
probably have two of these Powerphase100s. That'd be a Powerphase 200, a P squared 200, and have them linked through a fascinating program called Join Me. Is that
Yeah,
it?
join me. Yeah.
Join Me. Yes.
Join Me was helpful
We'll
today.
be able to link these two motors at the shaft with a online program called Join Me, and hopefully get something going here. But I'm kind of excited about the test benches that's coming along. Again, eventually we're going to have a GEVCU on the Siemens, so I can use that as a load and actually adjust
Yeah, you can vary
the
what.
level of regenerative braking
Yep.
with the throttle on it
Yeah.
to vary the load and
Really
watch the
test it.
power output
Yeah.
and watch the on screen
And so you'll be able to see the power input,
and the power.
output, and measure all the efficiencies. And
Well, it dawned on me today that we could then reverse that
absolutely.
and make this one the motor
Yeah.
and this one the
Yeah.
generator,
Yeah.
and do the same thing the other way.
Mm-hmm.
So should be good times.
Yes, it should.
In the future.
Tonight it's going to be nice.
And then we've got yet another bench going on over there, and we're again going to use one of these two new packs. I didn't feel I could sell them because they were kind of one-offs.
Yeah.
You know, what would I tell anybody about them? I didn't know anything about it. I didn't know they were the same modules.
Well, they were supposed to be different.
They were supposed to be different, and but I'm kind of delighted with them as test bench packs
they're great.
because I don't care how heavy the base is in this case, and so we'll have bench 3 with Reinhardt and a Scott, and this with the UQM Powerphase, and just keep after it.
Yeah, it'll be nice.
So that's kind of what I did on my summer vacation this week. And you're back to Ohio?
I'm back to Ohio and back to work Monday. So, yeah.
back to the salt mine.
Yes, indeed. Never ends.
Well, I want to thank you for coming out and stopping by for a couple of days. I think you
great
stopped
time.
by to get 6 battery straps. We've loaded down his van
Back to the
wearing.
van, heavy.
He'll need new tires by the time he gets to Ohio. But
Yes, indeed.
new suspension work.
Yep.
But that's it's been a pleasure to work with you, and I just wish we hadn't gotten our ass kicked.
Well, I really would have liked to seen it spin, but we made a lot of progress.
Yeah.
It's close, very close.
Yeah, I learned a lot.
Yeah, I did too.
I feel pretty comfortable with that.
And that's the fun part of it.
Yeah.
So,
And I've got a little GEVCU object module I can punch bits and bytes into and recompile it and send it. And I've only done that about 1,200 times since yesterday morning.
well, the good part is now the speed, the ease of doing the others, the Reinhardt and the
Yeah.
Scott it's going to be there.
Yeah, I've kind of got a model
You've
for
got
it now.
that one whipped. So,
Yeah.
yeah,
So
that'll be good.
anyway, back to you, Brain.
That's fun in the shop for days
It's
on
like
end.
2 old guys with a bunch of electrical equipment and a couple of computers. You can pretty much fuck around for 3 or 4 days.
That's right.
Just
That's right.
pretty much get with it.
That's right. You can miss the entire end of the week.
I kind of think of it as 21st century man cave.
There you go.
It sounds different, and it is different.
It is. It is.
And so
But cool. Close, huh? What do you think?
I'm becoming enamored of these battery packs we got.
I know.
And we sold a bunch of them.
Yes.
And you guys kind of stumbled into something. Here is a couple of our cells. I've got the new 35 millimeter straps in
We do.
that make this actually work quite well. However, I think a lot of people are going to leave them in the modules, in the packs. Not in the original packs, but they break into
in those
3
16, yeah.
things. But
Yeah.
some people are breaking them down to go with lower voltages and put them in parallel and so forth. So it's, but I assumed that it's kind of a thin metal, and I assumed this was just sort of some thin sheet, kind of flimsy, with 4 pouch cells in it, and somehow cobbled together to these terminals. Found a guy on the internet who was building a bicycle.
Okay.
Decided to take these apart. I gotta show you. I'm kind of stealing his video. I did request permission to use it, but I've never heard from him since.
Well, as long as you give the proper citation, like it's this dude's video.
All right, it's this dude's video, and we're stealing it.
There you go.
And we appreciate it.
Thank you.
And admire what you've done.
Yes.
So, take a look.
Alright, so I got a hold of some Nissan Leaf batteries, and you guys probably know what they look like from all the pictures online. These are pretty much what they are. Nissan Leaf has 48 stick stacks in series, and these are just one of them. Now I'm going to go ahead and show you how to disassemble this cell pack to salvage the cells. I have some tools here. I got some gloves. I'm not going to be using them for this demo just because I lose my dexterity. But if you are worried about your dexterity, worried about your skins, I got some cut from opening some of the previous one. Then go ahead and do it. But I think I got enough experience now. Electrical tape. You need these to kind of seal off the terminals so that it doesn't short each other out. So you don't want to do that. I haven't gotten short, but just in case. Scissor, of course, to cut these electrical tape. I just use like a flathead screwdriver, and the only reason why I use this is to remove this. There's spacers in there, and I'll show you what they are once we get to that point. But that's the only reason why I use these flathead screwdriver. A small one would do. You definitely need a wire cutter. Again, this is soft aluminum, so this wire cutter will be plenty enough to cut in through the aluminum. So you don't have to have something heavy duty. And finally, most importantly, the sardine can opener. And the reason why you need this is because, you know, this is actually like a sardine can, as you guys can see. And so it's only proper to use the right tools for the right job. So let's go ahead and get started. So right now I'm gonna keep the cells arrive with this tape on top of it, on the top of the terminals. I would keep them on for now, but later on you won't need them because you'll be using electrical tape. So the cells are like so, and they're kind of bent. The edges are kind of bent on so that they're held together. The important thing to note is that there's actually holes and openings at the edges here. Don't know exactly what they are for. Probably air cooling or the way they mounted in the Nissan Leaf, but they're important later on when you need to disassemble them. So go ahead and start your sardine can opener. You know, so there's really, the way I would do it is I would start from this corner, you know, because my can opener, you know, rotates this way, so it's going to be migrating along the way. Similarly, when I do it on the other side, I would start from this corner. You don't want to cut this thing onto this corner just because that's where the terminals are. So let's go ahead and do that. Don't worry about this because the cell itself is in the center. The edges are not anywhere near the cells, so therefore you don't run the risk into cutting into those parts. So I'm going to go ahead and cut into this cell here. I would go to the edge of the table just because it's a lot easier for me to rotate because my can opener's handle is a little big. No need to press down too tight except for the corners here. And the reason is because the corners are kind of a little difficult to handle, but you know, you get to the point of it. Once you get past, there's no need to press that hard. The can opener itself should be sharp enough to cut into these soft aluminum. So I've done this a couple times already. I got probably 4 of these already open, so that's why I'm doing this fast. But for you people who have never done this before, I recommend you to take some time to actually learn it. Now, these are soft aluminum. Nevertheless, they still can cut you like I did here. So be careful at the edges, especially when you just using these can openers. They're like sharp edges and whatnot. So just kind of peel them off here at the edges like so. Otherwise, next time when you put your hand near there, it will get cut. These things are not sharp enough to cut many things, but your skin they will. So as you can see, after doing this, there's still like a little piece of metal that isn't fully cut. So you know, this can opener is great in the sense that I can go forward, but not for too long. And just, you know, back and forth until it cuts it. So there you have it. That's one side. And I'm gonna go ahead and do this side, and I'll probably fast forward the video. Alright, so it looks like I got, for the most part, all of it except for this corner here. So let's go ahead and finish the job there. And yeah, my sardine can opener has the ability to go forward. I would just go back and forth a couple times. And it looks like it did a job. If it doesn't, use your wire cutter and that will do it. So that is just removing the top. Now there's adhesive in the center, as so. And so as you're peeling this off, you know, that's what you need to get rid of. Before proceed any further, you know, I'll be moving the edges, cleaning the edges of those soft aluminum pieces. So make sure that everything is cut, and if it helps, you can use that screwdriver and whatnot to peel off these things. Once you got that, I would just peel as so. As you can see inside, there's, you know, the aluminum cover, there's the blue protective case, and then of course the cell itself. Not sure you can see from this, but that's what it is. And of course there's some other stuff I can talk about later. But the way you remove this is you would peel as if you're peeling open a can opener. Now try to put your your hand on the blue stuff as you get leverage. So once you got that, just kind of peel this as far back as possible. Now if you get lucky, you can, remove some of these pieces, these joints. Last time I got lucky and they came off automatically, but if you don't, most likely you won't. There's ways you can cut into this. Hopefully you can see it. So there's 1 there, 2, 3, 4. These are the 4 joints that still keep this top lid, can lid on it. So what you need to do is get rid of that. And so use your handy wire cutter here. And so there's a sticky material here. Just leave that for now. And let's focus on getting this out. So I would just cut into as so. You don't have to worry too much about anything special. Just cut away. First ones will be a little difficult just because you don't have a lot of room. But work it from both sides. And again, they're very soft aluminum, so you should be able to easily cut them out. As you can see, once you cut it, it comes off because there's really nothing else holding it except for that curve. So similarly, on this other side, you would do the same thing as so. Much anyways. Alright, so anyways, got the lid off. These are what it looks like. So I'm going to leave that on the side for now. Now this is where you would use, I forgot to mention, but you will probably need some wax paper. You can probably do without it, but then again, this sticking on the table itself or any surfaces, and when you try to remove them, you will probably bend or try to bend this out because there's really nothing structurally holding this cells together other than the case itself, which you already removed. So, and I'll explain a little more when we get to that point. You'll see what I mean. So just get some wax paper. Get them from your Albertson, Bond stores or whatever supermarket store, and just lay them on there. Just for now, so that but you really don't have to do it now. I'm just kind of pointing that out right now. So what you want to do now is just go ahead and remove the cover there and get some electrical tape and cover up those leads because you're going to be working close by and you don't want them to short. So the next step is you need to, so before you would notice the top and the bottom has this groove, and the reason is because that's where the adhesive is. And so what you need to do is go ahead and remove the bottom cover. Now there's really no easy way just because there's nothing to cut. So what you really need to do is just remove the whole cell itself. But before you go any further, there's these 4 spacers that will fall out if you flip over. As you can see, this one came off already. The other one doesn't look like they want to. So that's when this tool comes into play. Just kind of push it out there. And not sure you can see them, but just pull them out. Reuse them for what you want, or go ahead and recycle it. It doesn't really matter. The aluminum, definitely it's aluminum, so it is recyclable. Just put them in your recycling bin and it should be fine. Anyways, so now that you have these top cover off, those spacer washer or spacers off, what you want to do is remove the bottom piece. And there's a couple ways you can do that. But the first step you need to prepare. And so you really need to kind of bend this down as so that you can pull this out of the 4 terminal pin cover, whatever those are called. So as so. I find it's easiest to use kind of the wire cutter that you have, that we don't have to have any other tools, and just kind of pull it back here. You already covered these ports, these terminals with it, so you shouldn't have any short. But be careful if you don't have this thing, because sometimes this aluminum will short between the two. It's highly improbable, but you never know. And you don't want to short these cells. You have a lot of energy in there. So finally, what you need to do next is, this is where I would probably use a glove. As you can see where I'm cutting, it's kind of very jagged. So just kind of bend this piece back a little bit. And similarly on the other side. If you find it difficult, it might help if you use this wire cutter a little bit here, just to peel this back. Alright, so the reason why you bend that back is because you need to essentially make a cut from this corner down somewhere like so. And then similarly on this side. You'll see it when I do this. So what we're going to do is just Alright, so at this point, you notice that there's actually 2 more holes on the bottom where the spacer used to stay. And it's actually advantageous for you to tap into them. And so what I mean by that is they give you some leverage to just easily cut into this section. And you will need to cut into this section. There is a plastic piece there, so just kind of cut the edges. Like so. It doesn't really matter you cut into this plastic piece. Again, you're not using it anyways at the end of the day. Alright, so that's that. So at this point, what I want to do is to split these 2 aside apart as far as possible. Now, you don't have to cut it, you don't have to split it all the way, just like so. And then finally, not sure you can see it, but I would want to move this piece and expose as much as possible, like an opening. Like so, kind of bend this back on each side. And as you can see inside, you will see a similar pattern. I'm not sure you can see it here. Let's see if I can get a flashlight on here. So there's the bottom plate, there's the blue piece, and then finally the cell itself. Similarly, just the exact same on the top. And the reason why that's important is you need to really remove that. And again, there's adhesive. So what you can do, if you're good enough, is to kind of just split that apart. But I wouldn't recommend that just because you really don't have leverage. Now, this terminal piece here, it's not really held on by anything. And as you notice, this cell itself is really fragile and flimsy. And so when you try to pull this off, you risk running the risk of just like ripping this whole front piece. Okay, so I'm back. The tools I was talking about is this large knife you call a machete. Now, I'm not going to cut into the cell, but I'll show you what's useful about it, how to disassemble this cell. And essentially the idea is you want to slip this through in between and peel off this adhesive so that you can literally remove it. It is going to be a little difficult, so I might have to adjust the camera a little bit so that you can see the whole picture. So raising this up a little bit here. Alright, so remember what I had before is I have this this 3-layer thing where there's the aluminum on the bottom, the blue piece in the middle, and then finally the cell itself. So what you want to do is hold the knife and slit it through between the aluminum. It's important now. Between the aluminum and the blue protector. And you never want to do it through the cell because you risk cutting into the cell. So the reason why I raised it up, the camera up, is what you want to do is something like I'm doing here, where so keep in mind the adhesive is where I'm pointing out right here, and so you want to put your machete somewhere pointing down that direction, and just wiggle it back and forth, sometime pulling it back out and restarting, and you will hear the adhesive breaking apart, coming off. And you kind of can see it. You can see this the the edge of the knife also through this. I can see it clearly. I'm not sure it shows up on the video or not, but you know, when you get to around like maybe 90% or 80% of the way, you will know to stop, and the last piece is just peeling it apart, and it becomes really easy. So this part is not terribly interesting, but essentially what I'm doing is back and forth motion on the cell itself, and just trying to remove it. You again, be gentle on this section of this tutorial. Alright, so I've gotten, for the most part, the whole thing off. Not the whole thing, but gone through the adhesive. And so, well, at this point, I'm going to remove the machete and go ahead and just split it. So now, at this point, you're pretty much covered, removed pretty much all of it already, and it should be easy to pull this apart. And so, once you pull this apart, that's pretty much it. So there you have it. You have the cells apart, and that's pretty much it. So that covers removing, separating the aluminum piece. Now initially I thought the aluminum piece, the case itself, was pretty heavy, and it's actually not. The bulk of the weight is inside the cell itself. The covering, I guess whatever these plastic pieces are, is not that heavy, so the bulk of the weight is within the cell itself. So I was hoping I can save a lot of weight, but it doesn't look like so. Alright, so this is what you had from last time after disassembling the cells. As you can see, you know, it's just the way it was before. Put the 2 wax paper off. I'm doing this outside, cutting the bus bar that I'll show you in a bit outside. So therefore there's a lot of wind, so it's better if you just kind of cut this wax paper so that it doesn't flop around too much. There will be 2 sides. I would note one at the top, one at the bottom, and I'll show you in a bit what they are. So I would actually denote this side as the top and this side as the bottom. You can't really tell now. You can't really tell if this is the bottom or this is the top, other than this, this padding that is on the bottom. And so here's some of the tools that I have that I'll need. Is the scissors just to cut the wax paper, but once you're done with that, you're good to go. Flathead screwdriver, definitely a Dremel tool. I try to cut it using one of these scissors or something, heavy duty scissor. It doesn't work too well, and I just have a Dyson to kind of clean up all the Dremel tool stuff. You'll want to have electrical tape also, because later on you want to seal up all the terminals. And of course there's always that handy wire cutter that you'll need to remove some of the stick-on glue that they have on the edges. And I'll show you what I mean when we get there. So yeah, so let's go ahead and start removing this. So the cells itself are protected by this plastic piece. And so this plastic piece is easily removed because there's 2 clips here, one here and then one on the other side. Just use your flathead and just kind of pop those clips there. Once they're off, they're pretty easy. I already actually popped this one already. So once you have that, it pulls off easily this top part. So there you go. It's removable. There's your 3 terminal. Now, as you remember, I said this is the top and this is the bottom. That's the only difference. Now you actually is clear to see because the top has these numbers or letters, whatever those are. And the top is where you want to attack the problem first, and then you go ahead and finish it off using the bottom. In fact, if you're good enough and you do experience enough, you probably don't even need to look at the bottom. The bottom is protected also by another piece here, which you can easily remove out. And so just go ahead and remove all that. Okay, so now let's get started. So, first thing is first is you need to remove these plastic pieces that are protecting the cells, that are holding the cells. And so they pop off easily, so don't worry about saying, these are kind of taped on. You pop them off one by one. And as you go, you pop one off, and then you Dremel tool a couple of them, remove them, and pop the next one, and so on. The way you pop those guys off is you would meet your trusty flat head screwdriver. So as you can see, on the edges here, there's these kind of glue that you can just pry off, as I'm doing here, and you're gonna need to pry those guys off before you can actually remove them. They're held on, they're just kind of, I'm not sure exactly what they are. They're like hardened glue, but they're not really glue. So there's one on one side, and then of course the inside that you need to pop off, and that's where I'm going to actually use my flathead. As you can see, that these are the cells here. What I would do is hold it to the tab and then just kind of pull it. Again, you can be a little rough on the cells here. This is a little tougher on that side to access, so I'm going to go ahead and try on this side. So let's see. Yeah, there you go. Yeah, so just kind of pull this off. And again, just play around with it. Turns out I'll probably be needing this flathead. So I'll go ahead and prop it out and then come back and I'll show you what I mean. So as you can see right there, I propped it off, and it becomes pretty easy to remove after that. I won't be able to do this while holding it this way because it's pretty difficult, but as you can see, I'm popping it off here already. Similarly, I did this on the same other. I did the same thing on the other side. So once you have that, then you can prop it off easily. There's still there's a hole here, and so the glue kind of flows past through. So what you want to do is use your trusty wire cutter and just cut that piece off, and then once you do that, then it becomes very easy to remove. And what I recommend is once you are able to remove one side, like so go ahead and I already cut that part off there. Once you are able to remove one side, like so, the other side is actually pretty easy to do because then you kind of just force it a little bit. Again, be careful not to damage the tabs there. If you damage the tabs, it's fine on this part where it's laminated. You can tell pretty well that when it's laminated, you can kind of damage that part, but you don't want to cut into this part here that I'm showing right now. And the reason is that's actually part of the cell already. And if you puncture those, you're gonna have to electrical tape those or seal those up somehow to prevent foreign elements to come into the cell and shorten your life of your cell or damage your cell. So some people might say, all right, why don't you just cut this part? Well, I mean, if you cut this part, you gotta be really damn careful not to cut into the cell itself to remove this thing. So I find it, it's probably easier just to mess with this and cut this part off. Alright, so here's what it looks like. So as you can see, there's kind of steps, or there is steps, and there's the 3 terminal. So the way I would attack this problem is, this is again based on experience. I actually cut like 3 of these already. So what you want to do is cut down here, the 2 sides, so you can remove these terminals. Then go ahead and cut the side here, and then that way you can access the first cell. And then of course once you access the first cell, you pull it back, and then of course you're going to start removing the plastic piece on the second piece. And then once you remove that, then go ahead and cut this, and then it will be exposed, so then you can cut the inside, and I'll show you what I mean afterwards. And you cut that part there, and then you remove the second cell and then the third cell. Similarly, you repeat the process, and eventually you'll cut everything off, and that's pretty much it. Alright, so I already removed the 2 terminal bus. That was pretty easy enough. I cut this side already. Now this side I wanted to cut using the Dremel tool also, but what I want to do beforehand is to actually generate some space out of this so that actually the Dremel can fit through this. Again, I would cut this one a little more carefully just because the way the Dremel tool actually rotates, it actually rotates counterclockwise. So therefore when you're spinning and trying to cut this, you're cutting it like this, what would happen is that you try to cut the side and then it'll actually spin out. And so what you want to do is just kind of drill right through in the center right here, through the side of the profile of the bus, the copper bus. So I'll go ahead and just kind of drill like this through the here. And once you got that, then you can remove the first cell off. Okay, so as you can see, what I have here is almost a finished product. Again, electrical tape those that are already sealed. I removed the plastic that's holding this last part. So now I'm only left with removing these two. And so the place where I would cut this now would be so let's see if I can get a clear shot here. Okay, so I would cut this part because you need to remove this bus here, and then of course the rest is pretty straightforward. Just cut these two sides and then you're done. And then yeah, remove the last plastic piece and then you got yourself this full cells exposed terminal exposed. Okay, so I got everything removed, electrical taped all the terminals, and that's pretty much it. And as you can see, there's the way that they configured it is there's this plus sign on each of those. I'm not sure you can see it, but that's to denote the positive. And so they would parallel these two guys together and parallel these two guys together, and that's how you got the 60 amp hours. And then similarly, you flip this around, you got your other positive side on the other side, and of course these two guys parallel each other, and then just connect those two, and then you got yourself your connect one of the two, and then there you go, you get your 7.4 amps or 7.6 volts, two parallel or two series. So yeah, once you get that, that's pretty much it. As you can see, I left a lot of that plastic, the glue stuff protecting it. I just remove all the plastic stuff. So yeah, and the back you can always remove also, but I would just leave it there again for protection, cell protection. So the next step after this would be to solder them to the proper configuration. So these are two positive, right? So what you want to do is to have in 4 series and 1 parallel. So the negative of this would have to go to the positive of the other one, and then the negative of this would have to go to the positive of this one, and then this guy would also go to this guy. So the way it would be connected is these two connect together, these two connect together, these two connect together with wire, and then finally these are the two terminals. And of course you can have your balance cable that comes out of it, but these are kind of the two terminals, the positive and negative of the 4 series. And then that's pretty much it.
Making electric boats isn't just making boats cleaner, it's making boats better. Being out in an electric boat means you can enjoy the environment you're in. You are so much more immersed in the sound and the experience of the aquatic life, of the water, of the wind, than you would otherwise be. And it really gives you a new level of understanding and enjoyment of that generally beautiful nature area you've gone into to enjoy yourself. What an electric motor does is that it gives you all this power in a vibrationless, soundless way. A well-thought-out, well-designed system has 100% of the torque available all the time. You don't have to build up to it, you have it. So when you pump the throttle, you are out there and your whole shot is amazing. It takes your center of gravity right out from under you, and it gives people that what they call the EV grin. You just start laughing, you can't help it. You're so conditioned to think that you first need vibration, then need noise, and then you start going somewhere. And in this case, your center of gravity just shoots right out from under you. And it's a wonderful feeling. You can still talk to each other. You're hearing the sound of the water and the wind and the waves instead of just hearing engine noise and vibrations. And it gives you really a chance to be in tune with that nature that you're actually out there to enjoy. Plus, not having to visit the pump is actually a great thing. Your battery will eat electricity from any source that you provide. I mean, who loves sitting around on your knees with a jerry can? We have better control over the boat. We have a better experience while we're out driving. Plus, we also have the knowledge that we're part of new technology. It is just way cool. Our mission is to make beautiful, fast, and fun electric boats. There's nothing more fun than taking these new technological developments and putting them into classic designs and having people shoot away with a big smile and an EV grin.
So it turns out, if you get a good, high-quality hand can opener
Oh, yeah.
and a 3 freaking foot long machete, and don't mind spending a week with it, you could pry one of these mostly open,
Yeah, almost open.
but not really apart.
Yeah, that's right. You don't ever get to the sardines inside.
The tabs on the pouch cells are done, I'm sure, with one of those ultrasonic welders in like a 8x8 or 10x10 dot pattern,
man.
firmly that he actually sawed the copper bus bars apart with a Dremel tool rather than try to separate them. I was impressed.
That's impressive. That's impressive.
And he never did get the
Never
four
got it
pouch
open.
cells apart.
That's pretty good.
He made some little plastic pieces kind of tucked down in there, but it's
It wasn't success.
these are pretty tough.
I know they don't seem like it, but
cells.
yeah, they are. Thanks for showing us.
I'm working on another little project. We'll see what shows up in the mail next week, but stay tuned for more battery goodness and more motor goodness,
Yes.
and more inverter goodness, and GEVCU is turning out to be a
Pretty good.
Thing.
Pretty good product. Absolutely.
yeah. We're it's gonna be a can opener.
I think so. That's really what it's going to be.
In fact, I may take one and just make a can analyzer out of it, dump all the GEVCU software, and just do a little can capture box for me. See what I can do with that. What else you got?
I don't have anything else.
How did our sale go this week?
We sold 1, 2, 3, 4, 5 of the motors sold. The last one today, an hour before the sale ended.
Is that right?
Yes.
Well, that's excellent.
Yes.
I never know what to expect or what you guys want. We could have sold 50 or none,
Right.
and I wouldn't have been able to tell.
No, we couldn't have been able to predict. No.
You all are somewhat difficult to predict. I can knock $1,500 off, and we close it Friday noon, and 3 of you order afterwards just because you were suspicious of that low price. And on the other hand, we run out of batteries by Thursday.
That's right. By Thursday night, we run out of batteries.
So it's fun to experiment. Our thanks to our friends at High Performance Electric Vehicle Systems for participating in this little event. And as I've kind of said, I actually consider that our crate motor.
Yes. Yes.
That's the one that they do good documentation for it. Well, I had a guy with a list of 10 questions that were really kind of, he'd sent them to you 3 or 4 times. I
Yes.
finally typed up a response, but not even sure I knew the answers. They were kind of,
No, and then he
questions.
responded back again. So I think it's all cool.
is it?
Yeah.
Is he happy?
Yeah, and
Most of it was in there. They have excellent
Yeah, they do.
documentation, good drawings, charts. He's got his own dynamometer now.
Yep.
And an expanding product line. They now have an AC34
Yes.
X2,
Yes.
believe it or not. And this is, it's kind of like the AC75 and 76. This is to, let me see if I get this right, extend the RPM band
Yes.
if you're using the older controller.
If you're
is that
using
right?
if you're using the 1238 controller,
right. And so it's wound a little differently,
It
but
is-
basically the same.
it is wound a
thing.
little differently.
His product line, my only criticism is it's not really a criticism. It just makes it difficult for me. Is it's getting to be very complicated
Yeah, there's a lot of stuff.
to know which to recommend for what application. He's kind of covering almost anything you'd want to do up, I'd say, to 4,500 or 5,000 pounds.
Yeah, he can produce some torque and some RPM out of those motors.
Right.
Yeah.
Again, for a daily driver, not for a race car. But,
Right.
And so I think it's, they're kind of our crate motor. That's what we recommend to our non-engineering
Right. You
segment.
just want to put something together, and you don't want to have to
kind of comes in a
Yep.
box with the whole kit and
harnesses all the parts. yeah.
harnesses and so forth. So that's our AC crate motor, and all of them are under $10,000, which used to be the holy grail.
Right. Trying to
And,
get a big AC system for under
So
10
you
grand.
can do from a small car up to a pretty substantial one. And I understand that he kind of caught boat fever at Epcot.
He did, especially Brian.
Well, he's the guy that counts.
That's
He's
right.
the one, he's
He
the one
really
that
caught
designs
it.
stuff.
Yeah, and he really caught it. Yeah.
And so they're doing, what's the gist of this motor?
I mean, they're doing we don't have any prototypes we can show you a photo of yet, but they keep things close to the chest, and they're
And we're big blabbermouths.
yeah, we can't help it. But so they're doing a motor for a marine application. It is going to be, I believe, stainless steel outer casing with aluminum end bells that'll be anodized and be real pretty. And they are going to, instead of jacketing the motor for liquid cooling, which will be their first
This
liquid
is going to
cooled,
be kind of innovative.
they're going to drive a non-conductive oil through
Through the motor.
through the motor. Yeah,
Through the air gap.
yeah, yeah,
And the stator.
yeah.
Through the windings.
Yeah, it's going to be cool.
Mineral oil thing. Do you know where I heard about this concept first?
No.
Our little buddy, Matt Hauber.
Oh, I thought maybe SpongeBob or something.
No.
Matt Hauber. Okay.
Hauber was telling me about this thing he saw on YouTube or somewhere where they ran a PC in a
Yes.
fish tank full of this non-conductive
That's
mineral
right.
oil.
That's right. I remember us
and
watching
he
that.
wanted to do a DC motor that way.
Yep.
And I wasn't, I suppose, very encouraging. And I still think it'd be kind of a problem with the brushes, Matt.
But an AC motor, yeah.
But on an AC motor,
Yeah. Why not?
I guess it's a matter of proper shopping for sealed bearings, huh?
Yeah, really, just that'd be the only place you could leak would be at the end belt bearings. Yeah.
Anyway, you're going to circulate this mineral oil through it and then do a heat exchanger. Now, in a boat, you're never far from cooling water.
No.
So then you run that through a heat exchanger outside the boat down below the water line, and you can get rid of a bunch of heat.
You get rid of heat really quickly. Yeah.
So, again, you're not supposed to know about it, and you didn't hear about it here first.
No.
Because it'll get us in big trouble with HP EVS. But
And this video will self-destruct in 7 seconds.
that's right. Your job if you choose to accept it. And so that's with our sale. I don't really have anything for the next week, but we'll come up with something else somewhere along the line. I kind of like having those, see what happens.
It's fun. Yeah.
It's kind of fun.
Yep.
So that's kind of what I've got.
All right. That's what I've got.
Start the music. Let's go.
Let's go. Play the song, Maestro.
All right.
We'll see you next week.
All right.
Here at Rockwell Automation's world headquarters, research has been proceeding to develop a line of automation products that establishes new standards for quality, technological leadership, and operating excellence. With customer success as our primary focus, work has been proceeding on the crudely conceived idea of an instrument that would not only provide inverse reactive current for use in unilateral phase detractors, but would also be capable of automatically synchronizing cardinal gram meters. Such an instrument, comprised of Dodge gears and bearings, Reliant electric motors, Allen Bradley controls, and all monitored by Rockwell software, is Rockwell Automation's retro encabulator. Now basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it's produced by the modial interaction of magnetoreluctance and capacitive diractance. The original machine had a base plate of prefamulated amulite surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were in a direct line with a panametric fam. The lineup consisted simply of 6 hydrocoptic Marsal vanes, so fitted to the ambifacient lunar wane shaft that side fumbling was effectively prevented. The main winding was of the normal Lotus-O deltoid type placed in panendermic semi-boloid slots of the stator. Every 7th conductor being connected by a non-reversible Tremi pipe to the differential girdle spring on the up end of the gram meters. Moreover, whenever fluorescent score motion is required, it may also be employed in conjunction with a drawn reciprocation dingle arm to reduce sinusoidal depleneration. The retroencabulator has now reached a high level of development, and it's being successfully used in the operation of Milford trunnions. It's available soon wherever Rockwell Automation products are sold.